Okay, so this video is about acids, and we're just looking at the basics of acids. So here are the formulas of some common acids that you must know. Nitric acid, HNO3, sulfuric acid, H2SO4, hydrochloric acid, HCl, and ethanoic acid, CH3COOH. Okay, you must know these formulas. These three here are what we call strong acids. This is a weak acid, ethanoic acid. If you look, they all contain hydrogen. Every single one of them contains hydrogen, and that's not a coincidence, because that is what makes an acid. An acid is a substance that can donate H plus ions in solution. So every one of those acids, if I just go back, can donate an H plus ion. This one will donate this one, this can donate two, this can donate this one here, and then this one, it can donate just this one here. Okay, so when they're in water, in solution, they can donate the H plus ion. And that H plus ion will go from the acid and it will join on to a water molecule to make the oxonium ion H3O plus. Okay, so sometimes we talk about acids donating H plus, and sometimes we talk about them forming the oxonium ion H3O plus. And we can get strong acids and weak acids. Okay, a strong acid is one that fully dissociates, and a weak acid is one that partially dissociates. Now, if we have a little look at what I mean by that, I've got a little program here. Okay, so this is a simulation. This is water here, water molecules. Okay, water partially dissociates itself. Okay, so if you've got two water molecules, they break up into the oxonium ion and the hydroxide ion. So if I just take away the solvent there, you can see there we've got the oxonium ion and the hydroxide ion, but we've also got a huge amount of water as well. Only a small amount of water dissociates. See, this reaction can go either way, it's reversible. Look at a strong acid. This HA represents a strong acid, any strong acid. And it interacts with the water, it reacts with the water, and it donates its H plus to make H3O plus. And we're left with the A minus. So if I just take away the water molecules there so we can see what's going on, you can see there's no HA left. It's all dissociated. I think it's dissociated means its bond's broken and it's split up into the ions. There's no HA left. So in a strong acid, the acid completely dissociates into H plus ions, which interact with the water, and the anion, the negative ion that's left over. If we look at a weak acid, okay, here you can see there's still a lot of HA left over. So we do have some oxonium ions, the H3O pluses. They're here and here and here and here and here, and we do have some of the A minus. That's the ion that's left once the H plus has been removed. We still have a lot of HA left over. And if you notice a difference, look at this reaction here. Let's compare it to the one before. Look at the arrow. That one, the reaction goes to completion. This one, it's reversible. Okay. This represents partial dissociation because not all of the acid dissociates into the ions. While in strong acids, it's complete dissociation. So that's where we get these lines here. Strong acids fully dissociate, weak acids partially dissociate. Okay.